maximum fruits harvested after at most k steps. Yeah, so for this problem, we are giving an array with the fruits. So inside the array, so it will be a subarray with the length of 2. So the first index is the position, and the second index is how many fruits. Yeah, and we are also giving a start position, for example at start position 5 and k is 4. So this means from station 5 this person can go 4 steps. Yeah, and we're gonna calculate the maximum fruits while meet the conditions from the start position to this k. Yeah, and for the first example, from 5 to 8, it is the maximum, it is 9. And for the second example, so this person can go left first step, and go back 2 steps, and go to right 2 steps. So in total, it will be 4 steps, and the total fruits will be 14. So it's gonna be the final result. Yeah. So for this problem, we can solve it by using prefix sum. So we can accumulate all the fruits in this 1D array. Yeah, so inside the 1D array, we prepare a prefix. So the second step gonna be how can we use this prefix to get the result. So for the person, yeah, for example, it is starting at position 5. So this person can go left or can go right. Yeah, so if the person go to the left, it must meet some condition. Yeah, to calculate where is the yeah, if the person go to right at 6, we must know some position the person can go to the left. It must be 3. So for example, if this person from 5 goes to 6, yeah, this is the right position. So the left position must be 3. If the person go to the left side, go to yeah, if the person stays at 5, so what is the left position? So the person intended to go to right, but the person stays at 5. So the left position would be 1. Yeah. Another way is the person intended to go left, but the person stays at 5. So what is the right position? Must be bigger. It is at 9 because k equal to 4. Yeah. So according to this kind of formula, we can get the position for the person at most to the left and to the right at most, and then we're gonna use the prefix sum to get the result. Yeah, actually this is a not so difficult to understand, but for the programming it would be a little bit harder because you need to take care of a lot of things. Yeah, because you need also to consider if the person goes out of the boundary, what's gonna happen. So if the person go to right, it may go out of the go to left, it may go out of the boundary. If the person go right, it may also go out of the boundary. Yeah, so we need to handle a lot of things. That is why this is gonna be a hard problem. Yeah. Now let me just start coding. So let me just start the prefix part. Yeah. So I'm gonna prepare a prefix array. Let me first prepare a variable n. So I'm gonna prepare a very longer array. So in this way, I don't need to consider what is the most position at the right. Yeah, later on I'm gonna optimize a little bit, but at the moment I will keep it a very big number. It's gonna be 10 to the power of 6. Why? Because the start position, it can be a very big number. It can be 2 to the power of 5. And this k can also be a very big number. It can be 2 to the power of 5. So maximum it's gonna be 4 times 10 to the power of 5 plus 2 if I prepare the prefix array. Yeah, but I'm gonna use a bigger number. It is 10 to the power of 6. Yeah. Now I'm gonna prepare the prefix array. It's gonna be 0 times this n. Now I'm gonna put the position and the value number of fruits inside the prefix array. So yeah, for position and count inside the fruits. So the prefix here I'm gonna use a position plus 1. Yeah, because I'm gonna use the prefix, and for the first index of the prefix I always keep it 0, so that's gonna be easy for the calculation. Yeah, so I'm gonna use a prefix plus 1. Yes. Let me explain a little bit. This will be something like 0, 1, 6, for example. So if I were to calculate the prefix sum from index 1 to index 2, I can directly use this 6 minus this 0. So the sum will be 6. Yeah. So this is why I'm going to use p plus 1 should equal to the count. Yeah. Now I'm gonna accumulate the prefix. Yeah. I'm gonna use a list accumulate with this prefix. So currently I got a prefix array. Yeah. And my start position would also plus equal to 1. Yeah, because I shifted the position of this p plus 1. Yeah, if I keep the first position as a 0, as you can see, it always is 0. But the fruit will be start at index 0. So I'm gonna shift it to 1. So this is why I here use p plus 1. And similarly for the start position, I'm gonna use the start position plus 1. It will be shifted to the next position. So this is just handle the edge cases. So I'm gonna shift a little bit for the positions. Yeah. Now I'm gonna check the result. So the result would be the maximum of a value. So I'm gonna prepare a result would be equal to 0, and finally I'm gonna return this result. Yeah. Now I'm gonna check the prefix. Now I'm gonna let me think. Yeah, currently I have the prefix array. Yeah, now I have the start position, and with this k, I'm gonna loop through this prefix array. Yeah, let me check what I'm gonna do. So yeah, currently I have the fruit array. If I can find the left position and the right position, the person can reach. Normally I can got the result. Yeah. So let me just start from the person. So for I in range of k plus 1. Yeah, because my first position, for example, this I, it means I didn't go any steps, but the maximum step is k. So k plus 1, this is for Python, because k plus 1 is not included. Yeah. Now I have two decisions. So the first decision is I intend to go. So the first condition is I intend to go to the left. Yeah. So the first position is I first have the left position. I intend to go to the left, and then I gonna calculate the maximum of the right. Yeah. But if I go to left, so there is a boundary. I need to consider this is 0. Yeah. So I'm gonna prepare a variable a. It would be the most left point I can reach. And then I'm gonna have a b. It is the right point I can reach, because I intend to go to left, but I'm still gonna keep the right position. So b is the right. Yeah. So it's gonna be the start position plus I. Yeah. So for the first position, I is 0. So the start position is just the start position. Yeah. So currently I will ignore this kind of mathematics handling. Yeah, actually this person will be at 6, but it doesn't matter for analyzing for the k steps. Yeah. So this person will stay at 5, but this person intend to go to the left. Yeah, but 5 is currently this person start position plus I 0, and 5 is the person can stay at the right. Yeah. Yeah, and this I will be increased, but now let me calculate the left position this person can reach. yeah, if the person can reach 1, next it will be 3 and 6, and next it will be 4 and 7. Yeah, so this is yeah, for if the person intended to go to left with the, yeah, if the person will go to the right with overlap, so it means that the person go to 5, go to 6 and 5, yeah, and go to 7 and 5, it will stay at 5. The person in, yeah, so the first one will be at the right side, there will be overlap. I'm gonna calculate the left side. Yeah, so first one it will be start position plus I, and then I'm gonna calculate the left. Yeah, so the left index would be start position minus k. So for example, this is the start position is 5, this k is 4. So 5 minus 4, it is 1. So it means that the person stays at 1, but it's gonna be plus 2 times I. Yeah, for the first step, I equal to 0, so this a stays at 1. But for the second one, this I equals to 1, and here this 2 plus 1, it's gonna be shifted from 1 to 3. So this is the left boundary. Yeah, but I also need to check the boundary. So it's gonna be the minimum of this one with the start position. Yeah, because if the person will be at the left, it can never be bigger than the start position, because A will be always at the left side. Yeah, but I also need to check a max from 0 to the minimum of the result. Yeah. Yeah, if my calculation is right, I think it will be like this. So this is the first step. So at the left, it will, yeah, so there are such cases, it will be bigger than this start position. So even, so for example, this I will go to 7, 2 steps, and if it go to 8, for example, it will go back. So this A will become 7, and B will become 6. Yeah. But B will always be at the right, A will always be at the left, so that is why we're gonna have a minimum. And for the maximum, we have a 0, because this person can never go to outside of this 0 position, so I'm gonna have a maximum. Yeah. So this is gonna be a little bit hard. You will take most of the time to calculate about this A and B. And similarly for this C and D, it's gonna be the same. Yeah. So this means the person will have the overlap at the at the left position. So it means, yeah. So it means there will always overlap at the left. It means that the person will start from the left first. It may be start from 5 to 4 and go back. Maybe 5 to 3 and go back. Yeah. So for the right, it's gonna be the start position. Yeah, let me check. Yeah, it will be the start position plus I. It will be the, yeah, but here, yeah, let me think. This B is I. It means it can reach 9, but actually, yeah, let me think. This is C would be the start position plus a K minus 2i. Yeah, this means if I equal to 0, so the start position will be 5 plus k. It is a 9. Yeah, it means C is at the right. C is at the right side. Yeah, so C is at the right side, but I'm gonna prepare C to be the left side, so I'm gonna change a little bit. So here, this is C, gonna be start position minus 1, and D would be the start position plus k minus 2i. So this means, yeah, for the first step, I'm gonna stay at 5. Yeah. If I stay at 5, but I'm going to go to the left side, but for the right side, I will be 9. And then my start position will minus 1, it's gonna be 4, and here will be 7. Yeah. And for this A and B, let's check again. For the start position is 5. Yeah. But my start position minus this k plus 2i is gonna be 1. So in this way, the left side and the right side always covered. It means it is everything for the result. Yeah. Now I need to consider this left side A and C. So if A more than and equal to 1, or C more than and equal to 1. So this means yeah, I can directly use the prefix to get the result. Yeah, so the prefix would be similar. It's gonna be, yeah, would be simple enough. It would be prefix B minus prefix A minus 1, and with the prefix D minus prefix C minus 1. Yeah, because the index is always more than or equal to 1. If the index is 0, you should know that 0 minus 1 is minus 1. It's negative 1. It can cause some yeah, wrong result. So this is why we have to check. So if A equal to 0, yeah, it's not the return. It would be result equal to 8. Yeah, so the result would be equal to the maximum of result with prefix B directly. Or another case, yeah, if C equal to 0, so the result would be the maximum of result with prefix of D. Yeah. At the beginning, I forgot about those two boundary conditions. It took me a lot of time to figure out why it is wrong. Yeah, I needed to consider these boundary conditions because this A minus 1 can never be a negative value. It can only be, yeah, minimum 0. Yeah, so this is why. Now let me think if something is also wrong. So for this C, this start position minus I can be a negative value, but it can never be a negative value. Yeah, so I also need to check the maximum. It's gonna be maximum 0. Now let me think. I think it's enough. Yeah, let me just run it to check if it works. Wrong answer. Yeah, there's some wrong result. Yeah, I passed some testing cases, but for this one, I got a wrong answer. Yeah, let me just print out the ABCD to check why. Yeah. Oh, it's difficult to check, I believe. Yeah, because this testing case is really long. Yeah, so there must be some mistake while I'm checking this A, B, C, and D. Yeah, let me compare with some of my previous coding. Yeah, I think it's gonna be from this A, B, C, and D. Let me check if yeah, I think I forgot to consider this D. Yeah, because at the right side, this D should also be checked. It's gonna be the minimum of the start position with the start position plus k minus 2i. Yeah, because this person gonna go to the right, but it can never go to left. Yeah, so sometimes if the person go to the left first, go to 4, it will go back, go to 3, it's gonna go back. Maybe this person can still go to 2. Yeah, but while it go back, it can never be 5, it may be 3, but our maximum position would be 5. So this is why I need to check this start position. Yeah, now let me just run it to check. Yeah, I think here gonna be the maximum. The right position would be the minimum. Yeah, it's gonna be the maximum. Yeah, it's not the minimum. It is the maximum because this start position will be a bigger value. But if it is smaller, it's gonna have the start position. Yeah. Yeah, as you can see now it works. Let me first submit it and then optimize a little bit about everything. So this is gonna be a long video, but I think it's worth it. Yeah, because there are so many tricks. As you can see it passed, but it's really slow, nearly 5% of all Python 3 submissions. But the time complexity is still on. Why it consumes time? Because this n is really big. Now let's try to prepare a smaller value of the n. So we can use a maximum of a. So for AB inside the fruits. Now inside the fruits, we're gonna use 0 times. Yeah, we're gonna check the longest of the prefix array. It's gonna be n plus k plus the start position. Yeah, we're gonna basically check the right side, maximum of the right side. Yeah, so we're gonna prepare a longer prefix, but this one gonna be much shorter because this n is the maximum position plus k. This k means it can go to the right, and this start may be at the start position. Yeah, so I'm gonna use yeah, because the start position is never mentioned, but the start position have a maximum value. So this is why I'm gonna plus a start position. But for the prefix array, normally I gonna plus a 2. Yeah, because I gonna use the prefix like b minus prefix a. I will keep enough index. Now let me submit it. Yeah, now as you can see, it is much faster. It's nearly 19%. Yeah. Now let's try to optimize a little bit about the boundary. I think we don't need to go to all this k plus 1. Yeah, because as you can see, if I use this k plus 1, there's a lot of max boundaries cases I need to think. Otherwise, I gonna have a wrong answer. Maybe I don't need it. Yeah, maybe this k don't need that much. Yeah, because for this person, if this person gonna go to the right side, if the right side just have the overlap, I don't know. Let me check this. Yeah, if the person gonna go to the right side, it can only go to 7 if it go from the left first. Yeah, maybe here I can use k plus 1 divided by 2 to make it faster. Let me just run it first to check if this works. As you can see, it also works. Yeah, because this person go to left first and go to the right can never be bigger than that, so I'm gonna use it is not right, there's something wrong. Yeah, so I will just keep it k plus 1. Yeah, because it's gonna be take even more time for the video, but just for this video I will keep it like this. We just need to think about the right side and the left side of the boundary, and then get the final result. Yeah, and